Hi everyone. The first question is, at 300 kelvins, the molar conductivity of aqueous solution of 3 salts of 2 different concentrations have given below. The conductivity of a saturated aqueous solution of AgCl is 1.4 into 10 power minus 6 Simon per centimeter at 300 kelvins. If the solubility of AgCl in water at 300 kelvins is x moles per liter, then log of x inverse we have to find out. What are the given there? Assume that, what is that? Assume that AgCl dissolved in ionizes completely and that molar conductivity of saturated AgCl he is considering as limiting molar conductivity. So just you have to find out solubility. To find out solubility, what you have that? Lambda naught m of AgCl is equal to K into 1000 by solubility. Yes, we have already the value K, because they given that conductivity of saturated AgCl, that is 1.4 into 10 power minus 6. So just you have to find out lambda naught m of AgCl. For that he has given a clue right side, that is the molar conductivity of 3 different salts. By applying Kohlrausch law, we have to find out molar conductivity of AgCl. How to find out that? That is lambda naught m of AgCl is equal to lambda naught m of AgNO3 plus lambda naught m of NaCl minus lambda naught m of NaNO3. You will get that lambda naught m of AgCl. To calculate limiting molar conductivity of AgCl, which is nothing but molar conductivity of saturated AgCl according to the given, we have to apply just Kohlrausch law to know the value. According to that, we can get the lambda naught m of AgCl. So he was not given these values also directly. To find out these values, he was given a clue, that is at concentrations, two different concentration, he was given molar conductivities. By using these, we have to find out each one. So for that, first find out the lambda naught m of NaNO3. Lambda naught m of NaNO3 is equal to how much? We have to find out. So lambda, any constant lambda m at a given concentration is equal to minus b root c plus of lambda naught m, according to Debye-Huckel-Ansager equation. We have molar conductivities at 0.01 and 0.04 for all the 3 salts. Substitute one by one. For NaNO3 salt solution, that is lambda m 111 is equal to minus b square root 0.01 plus lambda naught m. This is at concentration 0.01. Now you see that is 101 minus b under root of 0.04 lambda naught m. By using these two equations, I find out that lambda naught m of NaNO3 is equal to 121 Simon centimeter square mole inverse. Yes or no? Now go for the next. For the salt NaCl, same way we have to use. That is at 0.01 concentration, the molar conductivity is 117, that is minus of b root 0.01 plus lambda naught m. At 0.04 The molar conductance is 107. From these two, just by subtracting the values, we are getting lambda naught m value is 127 Simon centimeter square mole inverse for the NaCl, because the values are given Simon centimeter square mole inverse. This is for the salt NaCl. Likely we have to find out lambda naught m of AgNO3. Yes, lambda naught m of AgNO3 we have to find out. For this also lambda naught m, yes, previously it was given 125 and 116. 125 and 116 at 0.01 at 0.04. By using these two, we have to find out lambda naught m of AgNO3. We find that 134 Simon centimeter square mole inverse. After doing so calculation by subtracting one by one, because 0.01 means like this, 125 is equal to, that is 10 power minus 2, you can write as minus 0.1 b lambda naught. This is, from this you can write like this, 161, that is 2 into 10 power minus 2, that is 2 square, it become 2, 10 power minus 2 become 10 power minus 1, that is 0.2 b lambda naught. By multiplying the first equation with 2, after doing subtraction, you will get the lambda naught value. That lambda naught value, what you got is 134, what is that, Simon centimeter square and mole inverse. Already we got lambda naught of NaNO3, we got lambda naught of NaCl, as well we got lambda naught of AgNO3. From all these substituting in the previous equation, that is Kohlrausch law application, that is lambda naught of AgCl is equal to, that is lambda naught of AgNO3 plus lambda naught of NaCl minus lambda naught of NaNO3. By substituting all these values in this, you will get lambda naught m. Let us say this is equation 1. After substituting all these three values in the equation 1, lambda naught of AgCl is equal to 121, 134 for AgNO3 plus for NaCl we got that 127 minus of 121. After doing so, I got lambda naught of AgCl is equal to, that as 140. We got that Simon centimeter square mole inverse. So we have to find out solubility then. Then lambda naught m of AgCl is equal to K of AgCl into 1000 by molarity. That molarity is nothing but solubility. Say yes or no. Then we have to find out the value. Solubility is equal to K into 1000 by lambda naught m. That K value is was given in the equation previously itself as 1.4 into 10 power minus 6 into 10 power 3 by lambda naught m. Just now we got that 140. That means after substituting all the values, you will get that S value is equal to 10 power minus 5. That S value is nothing but he was given as X. See that if the solubility of AgCl in water at 300 kelvins, he was mentioned as X moles per liter. Therefore, this value I should consider as X. Then he is asking to find out that log of X inverse, that is log X value 10 power minus 5 whole inverse, that is equal to log 10 power 5, that is 5 log 10 the value should becomes 5. Therefore, for the given question, the answer is C. 5 is the correct thing. In the whole question, there are two applications are there. One is finding the limiting molar conductivity of weak electrolyte AgCl, and number 2 by using what is that Kohlrausch law application, and number 2 what is that other one, by using the Debye-Huckel-Onsager equation we are calculating individual molar conductance, limiting molar conductances of the given 3 salts at different concentration NaNO3, NaCl and AgNO3 we find out, and after substituting so you are getting the lambda naught m of AgCl. After that we are calculating the solubility, that is the question which is a easier and familiar type of question only. Now let us go for the next question, that is the correct order of O-NO bond angle in the given species is, there are given 4 species I think so. One is NO3 minus and one is NO2 and one is NO2 minus, yes or no, and one more is NO2 plus. These are the 4 species. Among them my correct answer is B. Sir, why do you go for that B answer? That NO2, if you know the structure you can write it. The structure is what is that, linear for NO2 plus. The bond angle is 180 degrees, and the next one is NO2. Since it is, the geometry is like this, having unpaired electron in this here, unpaired electron is present. If you go for the structure NO3 minus, trigonal planar. If you go for NO2 minus also, yes. So if you observe the structures and geometries, that is bond angle is 180 degrees, it is angular, okay, it is like sp2 trigonal planar, and the bond angle should be 120, but due to the presence of what is that unpaired electron, it has single electron, the single electron repulsions are lesser than bond pair repulsions. That's why the expected bond angle is more than the expected. And number 2, here NO3 minus, perfect trigonal planar, that's why the bond angle is 120 degrees. Here the bond angle should be 120, but due to lone pair and bond pair repulsion, here lone pair bond pair repulsions are more than bond pair repulsion. That's why the bond angle is lesser than the normal expected bond angle due to the more repulsions by lone pair and bond pair. That's why here the bond angle is less than 120 degrees. Because of trigonal planar structure, perfect trigonal planar structure, the bond angle is 120 degrees. Here the single bond electron pair repulsion, single electron bond pair repulsion is lesser than bond pair repulsion, which makes the bond angle is greater than the 120 degrees. This means this repulsion is more than the normal electron pair and bond pair repulsion, so that the bond angle is greater than 120. So according to the discussion we have completed just now, highest bond angle is NO2 plus, next what is this, NO2, next NO3 minus. These are the reasons which makes the correct bond order of the given species is NO2 plus, NO2, NO3 minus and NO2 minus. Now let us go for the next question, students. Okay students, let us go for the question number 3. Natural rubber on complete OH analysis gives a compound X as the major product. X gives the positive iodoform test and Tolan test. X on heating with aqueous sodium hydroxide gives Y as the major product. First of all, natural rubber. Natural rubber is a polymer of 2-methyl-1,3-butadiene. 2-methyl-1,3-butadiene. When it gets polymerization like this happened, then the polymer obtained will be like this. Natural rubber is a polymer of 2-methyl-1,3-butadiene or isoprene, which on what is that? OH analysis. Which on reductive OH analysis, because the reagent ozone zinc H2O is a reductive OH analysis. We are getting that. This is the compound. Actually, this is the technique how they have identified isoprene as the monomer for the natural rubber. In the reverse way, after taking up the rubber, upon OH analysis, they got this compound. So, when you go in the reverse manner, we are getting what is that, Nana? 2-methyl-1,3-butadiene as the monomer. So, this is the compound you are getting X. X gives positive iodoform test. S, because of methylated ketone, it gives positive iodoform test, and because of the aldehyde, which can give Tolan test. Now, X upon heating with sodium hydroxide solution, which means that is a intramolecular aldol condensation. Then what is the possibility? 1, 2, 3, 4, 5. That means this oxygen and these alpha hydrogens are gets condenses and the produces the compound A, option A. We are having, this is the intramolecular aldol condensation. This is also you can call that is crosser aldol condensation. Now let us go for the next question. Go for the next question, students. Yes. A known artificial sweetener X is a composed of 4-chloro-4-deoxy alpha D-galactose and 1,6-dichloro 1,6-dideoxy beta D fructose joined by a glycosidic linkage. Then the structure of the D-galactose is given below. So, based on this galactose structure, we have to frame the artificial sweetener X from the given data. Yes or no? 4-chloro-4-deoxy alpha D-galactose. For this, he was given that yes, it is going to there. Then we are getting alpha D-galactose. What is the general structure of alpha D-galactose? In alpha, the anomeric OH should be down, and the next OH is here, and the next OH is here, and the next OH is up, and the last CH2OH will be like this. This is the alpha D galactose. But in the question, there are 4-chloro-4-deoxy, that is alpha D galactose. What it means? This OH is 1, 2, 3, 4, replaced by chlorine, that is 4-chloro-4-deoxy alpha D galactose. Now, he is asking that 1,6-dichloro 1,6-dideoxy beta D fructose. What is the general structure of the fructose? Open chain structure, it is this is the open chain structure of the fructose. Now, it is going to attack and gives beta D fructose. What is the general structure of the beta D fructose? I am writing here. that is OH is up, CH2OH is down, and the OH is up and the OH is down, and CH2OH. It is the beta deoxy. This is alpha D galactose. This is beta D fructose. But what is saying that this is at first position. Let us say this is the anomeric 1, 1, 2, 3, 4, 5, 6. In fructose, second carbon is the anomeric carbon. The OH is upside, and he is saying that 1/6 position. This is the first position and this is the 6th position where the 2 chlorines are present. Now we have to connect this anomeric OHs. The anomeric OH of alpha D galactose and anomeric OH of beta D fructose. Okay. After connecting that, according to that, now it is OH is here, this OH is here, here is the chlorine, here is the OH. Now this alpha OH is going to connect. I am writing beta D glucose in opposite way. When you write in the opposite way, they becomes opposite, that like this CH2Cl is going to connect here. Now this OH is coming down and this OH is going up and this CH2OH is coming down, because we are making like this linkage. Then according to this, the answer become option A. So the given structure A is the correct structure of artificial sweetener X. Now go for the next question, students. Yes, this is the question based on chemical kinetics chapter. For a first order reaction, reactants become product at a given temperature. K is the rate constant. For the reaction at the given temperature, the concentration of reactant and product at time T are as given as concentration of R and P respectively. The correct graphical representations for the reaction is R. We know this is the reaction, we know that the familiar example of first order kinetics and graphs, reactant become product, then rate is equal to minus of dr by dt, which is equal to dp by dt, which is equal to K into concentration of reactant, because he was given that as first order kinetics. So for any reaction except for zero order, as the concentration of the product increases, as the concentration or the time increases, as the time is going on, the concentration of the product increases exponentially. The graph should be like this, but the graph never be like this. Therefore, option A is incorrect. Now we go for option B, that is dr by dt versus reactant concentration. According to the given equation, minus of dr by dt is equal to K into reactant power 1. That is dr by dt is equal to minus of K into concentration of reactant. It looks like y is equal to minus mx. Then the graph should be y equal to mx, that is passing through origin dr by dt versus reactant concentration passing through origin with a negative slope. Therefore, this given B option also be incorrect. Let us go for the option C, that is dp by dt versus T. dP by dt is equal to what I have given that? K into reactant concentration at a time T. According to first order kinetics, dP by dt is equal to reactant concentration at time T is equal to R naught into e power of minus KT. Yes or no? Since first order kinetics RT is equal to R naught into e power minus KT. Therefore, it looks like y is equal to some constant into e power minus kx. Say yes or no? That again exponential graph with decrease. Yes or no? Therefore, for the given C is the correct option for the given graph, because dP by dt versus of time. Now, the next option D, very easiest one I think so. Since rate constant and time, rate constant does not changes with time without increasing or decreasing the temperature, since he given that at the given temperature. So, rate constant remains constant as the time is going on. Therefore, option D also be correct for the given question. Therefore, the question first order kinetics, the graphical representations A and B are incorrect and C, D only are correct for the question. Go for the next one. Yes, this question is based on P Black, that to be 18th group, and somewhat mixed with general, what is that structures. Xenon and fluorine, if they are reacting in 1:5 ratio according to the given NCERT, that is Xe F4 is the P. XeF4 on O2F2 we are getting Q, that as XeF6. XeF6 on complete hydrolysis, yes, R is XeO3. So, P has two lone pair of electron on the central atom. P has two lone pair of electron on the central atom. If you observe the geometry and hybridization, you can know how many lone pairs are present. Generally, we are using steric number or hybridization number formula, that is surrounding atoms plus half into group number of the central atom, sum of valency of surrounding atom, either charge negative or positive, you do as addition and subtraction respectively. From that is xenon F4, 4 fluorines plus half into group number of xenon is 8 minus sum of valencies, that is 4 plus 2, that means that it has the sp3d2 hybridization, octahedral geometry, but due to the two lone pair it gets square planar shape. Yes, there are two lone pairs are present on the XeF4, that is P according to the question. Now, Q has a perfect octahedral geometry. Yes, Q. Actually, Q, that is XeF6 according to our answer. So, again you apply the same thing, steric number, that is 6 plus half into group number of central atom 8 minus sum of valencies 6, there is no charge, that is why, that is 6 plus half 1, that means it should be sp3d3 hybridization, and it should be pentagonal bipyramidal geometry, but due to the presence of one lone pair, it does not having, what is that, a perfect octahedral geometry. It is a distorted octahedral. The lone pair is a stereochemically active lone pair, which does not makes a perfect tetrahedral geometry in all conditions. Therefore, Q as a perfect octahedral is a wrong answer. Now, Q can act as a fluorinating agent. S, XeF6 act as a fluorinating agent. Next, the molecular structure of R is trigonal bipyramidal. Yes, in the same way, R is nothing but XeO3. If you go for that, 3 surrounding atom plus half into group number of central atom is 8 minus each valency of oxygen is 2, 3 2s are 6, then 3 plus that is equal to 1, that is sp3 hybridization, and the geometry should be tetrahedral geometry. Then if you are able to write that xenon, they are given, what is that, one lone pair, yes, and 3 bond pairs, that is oxygen, oxygen, oxygen. But oxygen valence is 2, but he was given as here single bond, that's why we are placing the pi bond. That pi bond must be the d pi p pi pi bond because the hybridization is sp3. So the geometry is tetrahedral, but the structure due to lone pair becomes a trigonal bipyramidal. Yes, trigonal pyramidal. That's why the option D is also be correct. So for the given question, A, C, D are the correct options. Now go for this question, 7th question, that is the correct statement regarding the periodic properties of the elements. Second ionization enthalpy of carbon atom is less than the top boron atom. See, boron and carbon. Generally, boron is 1s2, 2s2, 2p1. Carbon 1s2, 2s2, 2p2, whose electron configurations are. First, he mentioned that second ionization enthalpy. That means already my boron and carbon lost one electron and it become B plus and it become C plus. Then whose configurations become 1s2 and 2s2. Here carbon become 1s2, 2p2 carbon, I am sorry, that is a electronic configuration 1s2, 2s2, 2p2. Then it become 2s2 and 2p1. So the electron removal become typical from removing of electron from 2s orbital, filled or paired 2s orbital rather than unpaired 2p electron. That's why the second ionization enthalpy of carbon atom is less than the top boron atom is correct. Second ionization enthalpy of carbon atom is less than the top boron. Yes, the ionization enthalpy for the boron second ionization is more than the top carbon, since the electron removal become typical in the paired 2s electron rather than the unpaired 2p electron, which requires more energy because of having more attraction by the nucleus. Next, increasing order of ionic radii. You know that this is the regular question, that is Al plus 3, Mg plus 2, and you go for Na plus. The number of protons are 13, 12, 11. But the electrons become same, 10, 10, 10. These are isoelectronic species. For the isoelectronic species, as the atomic number increasing, size decreases due to effective nuclear charge increases here. That's why the sizes order be like this. Now go for the next one, option C. So increasing order, second ionization enthalpy of carbon atom is less than that of boron is correct. Increasing order of ionic radii, Al plus 3, Mg plus 2 and Na plus also be correct. Under identical condition in solid state, the density of the potassium metal is more than the density of sodium metal. Let us go for sizes first. Actually here density does not depends upon the mass, since if you compare the first A group metals, sizes: lithium, sodium, potassium. You see, rubidium, lithium, sodium, potassium, rubidium, and cesium. Along with a secondary also be, if you compare, beryllium, magnesium, calcium, strontium, barium. Do you know that one? Beryllium, okay, lithium. Beryllium size is lesser than, what is a lithium? Lithium size is lesser than magnesium. Magnesium size is bigger than sodium. Sodium is smaller than calcium, and all these things. My potassium is even bigger than barium. That means there is a large gap between the sodium and potassium in the sizes order. That means the volume is suddenly increases at potassium rather than sodium. When you compare, density is equal to mass by volume. When compared to mass increase from sodium to potassium, the size increase is very high for the potassium. As the size is more, density is less. So, density of sodium should be lesser than density of the potassium. But under identical condition in solid state, density of potassium metal is more than density of sodium metal is a wrong statement, because from here to here there is a large size increase. Do you know how much increase? Which is bigger than the all secondary group elements also. And number 2, why do they so? This is, what is that? 2s1, this is 3s1, this is 4s1, and that is the large difference in the sodium to potassium in size, which makes less denser than sodium. The HH bond is weaker than FF bond. No, HH is the stronger, what is that? Bond energy. That is exceptionally 1s as, okay, highest overlap when compared to fluorine. Here the lone pair of electron also makes less bond energy. So, HH bond is stronger than FF bond. That is also a wrong statement. So, the given question, for the given question, option A and B are the correct answers. Now, go for the next question. In the following reaction sequence, P, Q, S and T are the major products in the given scheme of reaction. First, acetic anhydride, aniline on acetic anhydride in the presence of pyridine, we are getting N-acetylation. S followed by constant HNO3 H2SO4, because it is a moderately activating group which makes the nitrogen at a para position. That is nothing but it is the P. Followed by hydrolysis. Due to that, it become NH2 and NO2. Followed by NaNO2 HCl, that is a diazotization mixture, which makes the compound is para-nitro-diazonium salt, which is a Q. Let us go for next one. What is that? Isopropyl benzene on O oxygen in the presence of hydrolysis, which makes into cumene hydrogen peroxide mechanism, which gives phenol and acetone, which on NaOHCO2, that is nothing but followed by hydrolysis, coal base reaction, which gives salicylic acid. This has the S. Now, which S coupled with Q, that is nothing but aromatic electrophilic substitution, which takes place with respect to activating group. Ring having the more activating group and diazonium salt having the, what is it, withdrawing group. The electrophilic substitution majorly occurred at para position. That is why OH, COOH, NN, this is the compound you are getting as a T. That means the Q is doing electrophilic substitution on salicylic acid. OH is the strongly activating group. With respect to that, reaction is occurred. Now Q on treatment with ethanol generates an aromatic aldehyde. Generally Q on ethanol, which causes reduction, that is will give nitrobenzene but not aldehyde. Therefore option A is wrong. Since diazonium salt, benzene diazonium salt upon ethanol or H3PO2, which makes reducing into benzene. That's why here paranitro gives nitrobenzene but does not the aromatic aldehyde. S gives a positive toluene ditest. Yes, to give positive toluene ditest, the phenol, where is the S? Here is the S. The S must have para hydrogen should be free. Since to form toluene ditest, the para hydrogens is going to substitution is occur, toluene ditest. Therefore in the S already para hydrogens are free, therefore it can be possible to give toluene ditest. Now P is a dinitro compound. Actually P is not a dinitro compound, it is a mononitro compound. Therefore C is again wrong. And T is a colored compound. Yes, these azo compounds are colored substances. Therefore for the given question, option B and D are the correct things. Now let us go for the next question, students. Yes, the correct statement regarding the sugars is, here he given in a logical way, L minus glucose, that means D plus glucose, alpha or specific rotation 52.5 degrees, L plus fructose, that means L minus fructose, specific rotation, that is minus 92.5 degrees. Did you observe the things, students? Now D-glucose on treatment with HNO3 or gluconic acid is oxidized to saccharic acid, whereas glucose is not oxidized to saccharic acid. The statement is wrong. Since either glucose or gluconic acid, both on oxidation by HNO3, both will give what is that? Saccharic acid. Both can give saccharic acid. Fructose gives positive Fehling's test because it isomerizes to glucose and another aldo exoses in the presence of Fehling's reagent. Not only Fehling's reagent, D-glucose, D-fructose, D-mannose. The three of them are equilibrium together in the basic media. Three of them gets equilibrium together in basic medium. Our Fehling's reagent or Toluene's reagent, both are having alkaline medium which gets isomerizes together. If I take fructose, which form glucose and mannose also. If I take glucose, which form fructose and mannose also. If I take mannose, which can also form D-glucose and D-fructose. We can call that as a Labre-de Bruyn and Eckstein rearrangement. Because of that reason, fructose gives Fehling test even though it has the ketonic functional group. Now, invert sugar is an equimolar mixture of D-glucose and D-fructose formed after hydrolysis of the corresponding disaccharide. Yes. What is the corresponding disaccharide? Sucrose. Sucrose is a dextrorotatory. Upon hydrolysis, it gives glucose and fructose in 1:1 ratio. Just now we saw glucose specific rotation 50.5 degrees. Fructose is minus 92.5 degrees. For their equimolar mixture, specific rotation is equal to 1 into 92.5, sorry, minus 92.5 plus 1 into 52.5, because number of moles are 1 by 1 plus 1, then alpha is equal to minus 20 degrees. That means the specific rotation of the mixture The specific rotation of the mixture after hydrolysis of sucrose is minus 20 degrees. But before, the sucrose solution is dextrorotatory. Therefore, the rotation of the optical rotation of sucrose, dextro become levo. That's why this is also called invert sugar. So, invert sugar is an equimolar mixture of D-glucose and D-fructose formed after hydrolysis of the corresponding disaccharide. Therefore, the option C is correct. Specific rotation of the invert sugar is minus 40. No, invert sugar minus 20, just now we calculated. Therefore, for the given question, option B and C are only correct answers. Let us go for the next question. The question which is from, what is that? From atomic structure, that is Xa plus and Yb plus are hydrogen-like species. The wavelength of the light absorbed during the transition between the states of principal quantum number n equal to 1 to 2 of Xa plus is lambda, and the wavelength of the light absorbed during the transition between the states with principal quantum number n equal to 2 to 4 of Yb plus B, Y plus B is 9 lambda. The lowest possible value of A plus B is, what is going to ask is, this is equal to 1, this is equal to 2. When my electron transition by absorbing wavelength absorbed, the electron gets from here to here. So, the wavelength of the light used is lambda. For the ion, Xa plus 1, 2, 3, 4. Yes, here that is n equal to 2 to n equal to 4 for absorbing. The energy or the light energy wavelength is 9 lambda. For the ion Y plus B, say yes or no? The lowest possible values of A plus B. This is the only clue they have given. One more important clue is here, hydrogen-like species. That means there is 2 are a single electron species. You know everybody from the equation 1 by lambda is equal to R into Z square into 1 by N1 square minus of N2 square, where N1 and 2 are N1 low energy and 2 higher energy levels in the atom, R Rydberg constant, Z atomic number. Apply this is for first ion Xa plus, then 1 by lambda of Xa plus ion, Xa plus ion is equal to R into Z of X ion into 1 by 1 square minus 1 by 2 square. Let us say this as equation 1. Same thing you apply for the second equation, that is 1 by 9 lambda is equal to R into Zy into 1 by 2 square minus 1 by 4 square. Let us say as equation 2. Now do equation 1 by equation 2. Let us do equation 1 by equation 2. Then what you are getting? RR gets cancelled. Then 1 by lambda, that is equal to 9 by 1. 9 is equal to, okay, Zx by Zy. Say yes or no? Zx by Zy into, that is equal to 3 by 4 by, that is 4 4s are 16 minus of, that is equal to 4. 4 minus 1, that is equal to 3 by 16, that is equal to directly I can write that Zx by Zy is equal to, we will get 9 by 4, which is nothing but 3 by 2. So, atomic number of the X ion atomic number of the Y ion, we got that Zx by Zy is equal to 3 by 2. Finally, we got that. Say yes or no? So, from the given that there are lowest values, the lowest possible values. Say yes or no? So, to get the lowest possible values, x a plus y b plus. If it is, for example, atomic number 2, helium. If it is atomic number 3, lithium. It should be single electron species. To become single electron species, it should be +1 and it should be +2. Therefore, the values of A and B, A equal to 1 and B equal to 2 are A is equal to 2, B is equal to 1. Since we cannot say which is 1, which is the helium and which is the lithium. So, A equal to 1 and B equal to 2 are the possible values. Then A plus B values is equal to 2 plus 1, that is equal to 3. Because it does not mention that the two ions, hydrogen like species are from what is that, lower to higher, and X is the helium and Y is the lithium, or Y is the lowest one, X is the highest one, it does not mention. That is why we can take any one of them, that is A plus and B plus, that is equal to X equal to, I am saying as helium and Y is equal to lithium. If it is A equal to 1, B is equal to 2. If X has the lithium and Y has the helium, then A equal to 2 and B is equal to 1. So, the lowest possible values for the given ions is nothing but 3. Now, let us go for the next question, students. Yes. At a given temperature, 0.45 grams of acetic acid in 50 ml of water is shaken with 1 gram of charcoal, and the pH of the solution, resulting solution is 3. Assume that adsorption of acetic acid from the aqueous solution by charcoal follows Friendlich absorption isotherm, that is x by m equal to k into c power 1 by n. If the plot of log x by m versus log c gives a straight line with slope 1, that is 1 by n is equal to 1. The value of k in liter per mole is, what is the given things? Molar mass of the acetic acid was given, the acid dissociation constant of acetic acid was given, x is the mass in grams of acetic acid adsorbed, m is the mass in grams of charcoal, c is the equilibrium concentration of acetic acid in the solution after is complete, what is that, adsorption is complete. That means acetic acid yes, what is saying, after the complete adsorption, what is that equilibrium constant, the equilibrium concentration of acetic acid was given. Okay, na? K and N are the constants of acetic acid charcoal system at the given temperature. What he is mentioning, let us see. Here acetic acid is there. How much is there? 0.5 gram of acetic acid and 50 ml of water. What it means? Molarity is equal to weight by gram molecular weight into 1000 by V. After doing so, W's is 0.1 m. So, the initial given acetic acid solution, molarity is equal to 0.15 initially. For this, what is added? 1 gram of charcoal. 1 gram of charcoal is added. Due to that, what happened? Generally, if you added charcoal to it, some of the acetic acid molecule goes to adsorb over by charcoal, which causes decrease in concentration. Due to adsorption on charcoal. Yes or no? Now we have to know what is the concentration of the charcoal after adsorption. We don't know that now. But for this, he was given a clue. What is that clue? The pH of the resulting solution is 3. That means already was mentioned the acetic acid solution after complete adsorption, it is in the equilibrium of state and H plus whose pH is equal to, he was given as 3, which means that the H plus concentration in the solution is 10 power of minus 3. This is the one clue he was given. Say yes or no? It is a weak acid, you know. That means acetic acid when dissociated. Yes or no? It is concentration C0. Then H plus concentration is equal to under root of Ka into C. You know everybody. He was given that as 10 power minus 3 under root of Ka value also he was given 10 power minus 5 into concentration of the acetic acid at equilibrium. Already they have given some initial concentration. After that it was dissociated after absorption. After adsorption it was dissociated at this equilibrium concentration. I want this is the concentration of C, that is equal to 10 power minus 6 is equal to 10 power minus 5 into C. Then concentration is equal to 0.1 m. For the after absorption, concentration of acetic acid solution. Say yes or no everybody. So he is asking to find out, so the change in concentration. How much change in concentration? That is equal to initially 0.1 m, finally 0.1 m, 0.15 and 0.1 m. So the change in concentration 0.05. The change in concentration is 0.05 is the change in concentration. That means this much of acetic acid has adsorbed over by charcoal. Say yes or no? How much charcoal? 1 gram of charcoal. So how much weight is going to adsorb? Molarity is equal to weight by molecular weight into 1000 by V. That means weight of acetic acid adsorbed is equal to 0.05 into 60 into volume of acetic acid solution 50 by 1000. This is the weight of acetic acid adsorbed over 1 gram of charcoal. This is the weight of acetic acid adsorbed over 1 gram of charcoal, that is equal to 0.15 gram. How much we got? 0.15 gram. So overall I found how much acetic acid is adsorbed over by 1 gram. This is also called extent of adsorption, X by M. What is X by M stands for? How much adsorbed over 1 gram of the adsorbent. Yes, I got 0.15 gram of acetic acid adsorbed over by 1 gram of carbon or charcoal. So this is, I can say that as the X by M. Now go for the next. That is X by M is equal to K into, what is the given example? K into C power 1 by N. Friendly absorption isotherm. Apply logarithm. Log of X by M is equal to 1 by N into log C plus of log K. It looks like Y is equal to mx plus C, students, where M is nothing but slope. Already M is equal to given as 1, that is 1 by N is equal to 1. So simply we have to find out log K, that means K value only we have to find out. Log of X by M you got 0.15 is equal to 1 into log C, Concentration of the acetic acid equilibrium is 0.1 and log K. After doing so, log K is equal to log of 1.5 you will get. Say yes or no? Then K value is equal to 1.5. Yes or no? Log of 0.1 I am bringing this side, that is equal to log 0.15 minus of log 0.1, log A minus log B equal to log A by B. After doing so, we are getting log K is equal to log 1.5. The K value is 1.5. The question also asked to find out the K value. The value of K in liter per mole, that is equal to 1.50. You have to write up to 2 decimals. Yes or no? Now, let us go for the next. Yes. Shall I? So, question number 12. In this, in a solvent S, a compound B is partially dissociated into C and D as products. According to the given equation, B becomes 2C and 2D. B, C, D are the non-volatile in nature. The molar mass of B is 10 times the molar mass of S. The standard boiling point and the standard enthalpy of vaporization are 400 S or 400 kelvins and 10 R joules per mole respectively, where R is the gas constant which was in joules per Kelvin per mole. A solution of B in S with the initial concentration of B as 0.25 mass percent or weight percentage has a boiling point of 408 kelvins at 1 bar pressure. The mole percentage of B that has been dissociated is. This question is from solution and colligative properties, especially on elevation in boiling point concept. So, the terms are looking jumbling, but if you clearly observe the question, the process and solving of the question is also very easy, but somewhat lengthier calculations. Let us go for one by one. Here, the first thing, solvent is S. Please remember that these things. Solvent is S and a compound B. Solute is B, which is partially dissociated into C and D, or these are also non-volatile in nature. The molar mass of B is 10 times the molar mass of S. Molar mass of the B is 10 times to the molar mass of the S. Yes, the standard boiling point and the standard enthalpy of vaporizations. Standard boiling point is 400 Kelvin, that is boiling point of the solvent. Enthalpy of vaporization of the S 10 R. Say yes or no? A solution of B in S with a initial concentration of B, that is 0.25 grams of B in 100 gram of solution is the meaning, because 0.25 weight percentage. Then weight of the B is equal to 0.25 grams and weight of the solvent is equal to 99.75 grams. This is the data one by one we can write from the given. And what is that? Boiling point of the solution is also given, that as 408. But initial boiling point of the solvent 400, boiling point of the solution after addition of the B is 408. That is change in boiling point or increase in boiling point, that is boiling point of the solution minus boiling point of the solvent. Yes, that is 408 minus of 400, that is equal to 8 kelvins. Elevation in boiling point is 8 kelvins. Then we have to calculate in the solution the mole percentage of B that has been dissociated. Given that B gives rise, that is 2C plus 2D. For the dissociation concept, degree of dissociation is equal to I minus 1 by N minus 1. Then alpha is equal to I minus 1 by the number of particles after dissociation are 4 minus 1, that is 4, 3. I is equal to 3 alpha, that is equal to 3 alpha plus 1 is the I. He is going to ask what is the percentage of dissociation. This is the data I can write from the given question. So, to calculate the alpha value, okay, we have to first apply delta TB is equal to I into Kb into molality. You have delta TB value. Now, I have I value, that is 3 alpha plus 1. I want to find out alpha itself. And M, I do not have Kb, I do not have molality. So, first of all, molality. Molality is equal to weight of the solute by gram molecular weight of the solute into 1000 by weight of the solvent. So, weight of the solute was given 0.25, molecular weight of the solute we do not know, and 1000 by, that is 99.75 is the weight of the solvent. Say yes or no? Then I got that molality is equal to 1000 by, what is that? 399 molecular weight of the B. Yes or no? After solving the equation. Now let us go for that calculation of Kb, that is abelioscopic constant. To calculate, we have the thing that is RT naught square molecular weight into 1000 into enthalpy of vaporization. Generally, the formula is RT naught square by 1000 into LV. LV means latent heat of vaporization, which is equal to enthalpy of vaporization by molecular weight of the solvent. Here Kb is equal to R into T naught, that is equal to 400 square into molecular weight of the solvent S by 1000 into enthalpy of vaporization. Yes, enthalpy of vaporization was given as 10 R. Yes or no? Then after calculating, you are getting that Kb value, what is that? 16 into Ms, I think so. Yes or no? So, you got the Kb value, you got the molality value also B. After substituting all these values, that is molality delta Tb is equal to 8, I is equal to 1 plus 3 alpha, Kb 16 into molecular weight of the solvent into 1000 by 399 into molecular weight of the solute. Already in the starting itself, he given that molecular weight of the solute is equal to 10 times to the molecular weight of the solvent. If I substitute here 10 ms, this cancel. After doing so, I will get the alpha value. Except alpha, everything is a known value. I got that 0.995 by 3. Then percentage of alpha, okay, you will get that percentage of alpha, that is 0.3316 like this. Then percentage of alpha equal to 33.16. We cannot get the value is exactly like this. We are getting some range. The range must be required for this question, especially here. This is the question we have from the solutions and colligative properties. From the data first, he was given the solvent molecular weight is what is that? 1 by 10 time of molecular weight of the solute, that is Mb is equal to 10 ms. He was given solvent boiling point, he was given enthalpy of vaporization of the solvent, and he was given one more clue, that is 0.25 weight percentage of solute, that is 25.25 grams is dissolved in 100 grams. By using this, I have drawn all the logics. I think you got everybody clarity regarding the question. Now, let us go for the next question, students. Yes, consider that coordinating atoms of the ligand cis and meridional, that is tetraamine dichloro cobalt 3 chloride, triamine trichlorido cobalt 3 complex are the vertices of a octahedron. The sum of the total number of triangular faces in both of the complexes having nitrogen atom and chlorine, nitrogen and 2 chlorines in this 2. So, here we have, what is that? 2 is possible, here we have 4 are possible. That means 2 plus 4, the answer become 6. Just if you want, I will show one of them. Cobalt, like this. Okay, the first compound is a cis isomer. Here is the ammonia, here is the ammonia, here is the ammonia, here is the ammonia. Therefore, this is a cis isomer. Like this. Now, the question in this I want to show you. You see, yes or no? What he is asking to you find out? The number of triangular faces in both complexes having 1 nitrogen atom and 2 chlorines. Let us see. This is chlorine, chlorine, nitrogen. So, this is the one triangular phase, chlorine, chlorine, nitrogen. This is one triangular phase. Like this, there are only 2 triangular phases. One triangular phase, one triangular phase. Like this, there are only 2 possibilities. Likely, here 4 possibilities are there. The total number of triangular faces for the both complexes in which 1 nitrogen and 2 chlorine atoms is 6. Now, let us go for the next question. Yes, it is the paragraph question, which is also again from same topic, solution colligative properties. So, there are 3 questions from solutions and colligative properties lesson of the physical chemistry. That is, 2 volatile liquids A and B forms an ideal solution. Consider a molar solution of B in A inside closed container having a total vapor pressure. Yeah, the total vapor pressure is 100 mm of Hg at 300 Kelvin. The vapor pressure of, so from the data, P total is equal to 100 mm of Hg. The vapor pressure of the pure A at 300 kelvins is 105. P naught A 105 mm of Hg. Assume A and B have a ideal gases in the vapor phase. Remaining molar mass of A given, molar mass of B given, R value was given, density of the liquid B at 300 kelvins given, and given the unit conversion 1 atmosphere also. At 300 Kelvin, the ratio of molar volume of pure B in vapor phase to its molar volume in liquid phase. Molar volume of B in vapor phase to molar volume of B in liquid phase is how much? He is going to ask. Say yes or no. First of all, according to that ideal gas equation, P total is equal to ideal solution. Okay, they mentioned as a ideal solution, that is P total is equal to P naught A XA plus of P naught B XB, which follows Raoult's law. PA equal to P naught A XA, PAB is equal to P naught B XB. The P total is equal to P naught A XA plus of P naught B XB. Now let us go for the substitution. Say yes or no. P total. So P total was given as 100. That is P naught A. What is that? P naught A and P naught B they were given. P naught A as 105 into what is that? Which is a 5 molar solution of B. That is 5 moles of B in 1 kg solvent. So number of moles of the B is equal to 5. Number of moles of the solvent A is equal to 1000 by molecular weight of A is equal to 50. You have this knowledge. Then apply mole fraction of A, number of moles of A, 1000 by 50 by 1000 by 50 plus of 5, because number of moles of B, plus P naught B into XB. XB is nothing but 5 by 1000 by 50 plus of 5. Okay, except that everything is a known value. What is that? Except P naught B. So from this I calculated P naught B, that has 80 mm of Hg. Say yes or no. I found what is the pure vapor pressure of the B from the given, what is that? Ideal solutions P naught A XA plus P naught B and XB. Now he is asking that molar volume. Okay, he is asking that molar volume in vapor phase. Say yes or no. Follows ideal gas equation, that is PV is equal to RT, then volume is equal to RT by P, that is equal to R. 0. He was mentioned only here 0.08 liters atmosphere per Kelvin per mole, and temperature was given as, what is the temperature? 300 kelvins by pressure 80 by 760, since it is the units of in liter atmosphere, na? That's why after changing, so I got that volume in 228, what is that? Liter per mole. Volume of the B in a vapor phase, I got it. But in the same question they asked to find out volume of the molar volume of the B in liquid phase also. In a liquid phase, vapor phase to liquid phase, that is equal to 57 by 0.5. Since what is that? 57 gram per mole. We have to convert into density also given 0.5 gram per mole. So 1 ml having 0.5 gram having 1 ml. 57 grams is having how much? 57 by 0.1 m, that is equal to 114 liters per mole. Say yes or no? Sir, milliliters. milliliter per mole. So, he is asking to get the ratio. Say yes or no? He is asking to get the ratio. So, how to calculate? Molar volume in vapor phase 228 liters per mole by what is that molar volume in liquid phase? We are already having 114 into 10 power minus 3. That is asking in a liters. After doing so, I will get the answer 2000. It is the ratio we are getting from the molar volume in vapor phase and the molar volume in a liquid phase. Now go for the next question. Yes, for the same paragraph, the mole fraction of B in vapor phase which is in equilibrium with the solution. Mole fraction of B in vapor phase. Yeah, here two liquids A and B is there. Here he is asking to find out mole fraction of B in vapor phase. Say yes or no? Generally, according to the Raoult's law, PB is equal to XB into P naught B. What is PB? Partial pressure of the B is always directly proportional to mole fraction of the B in the solution. Say yes or no? Previously only mole fraction I got 0.2 and P naught B I got 80 mm of Hg. Then we will get that 8 2s are 16. That is partial pressure of the B in the vapor phase I was found. Say yes or no? According to the Raoult's law, Ya into P total is equal to Pb, because mole fraction into total pressure is equal to partial pressure, because it is a gas-gas mixture. Then Ya is equal to Pb by P total. Pb you got that 16, P total is equal to 100. I thought. So yes, it was given as 100. So that is equal to 0.16 should be the answer. Here we applied first, what is that? Raoult's law. I got that vapor pressure of the B, partial vapor pressure of the B. After then, by using the ideal, what is that? The idea, what is the Dalton's law in the gaseous mixture? Here is the gaseous mixture of A and B vapors. So mole fraction into its total pressure is equal to, what is that? Partial pressure. Ya equal to PAB by PT. Then you are getting that answer 0.16. Okay. Thank you very much, students. This is the questions regarding physical and inorganic. For the next question, in the following reaction sequence, major products are X and Y are acyclic monomers. Methyl iodide on KCN, it should give CN only according to HSAB principle, because it undergo SN2 mechanism. That soft nucleoelectrophile is attacked by soft nucleophile of carbon. That's why we are getting cyanide as the major. Upon hydrolysis, we are getting carboxylic acid, that is acetic acid. On red phosphorus bromine, which is a HVZ reaction, Hell-Vollard-Zelansky reaction, alpha bromination is occurred, followed by excess ammonia. Why do they mention excess? Mean if you not mention excess, that some of the ammonia is consumed by acetic acid, there is no SN2 mechanism. That's why to get substitution at this position, we are taking excess. Let us say is X. Now caprolactam, everybody knows that. Caprolactam. Okay, 1, 2, 3, 4, 5. Six, and here it should be one more. 7. Which on hydrolysis we are getting 6 amino caproic acid. This as the Y. Now he is going to ask what happened? 500 moles of X completely reacts with 500 moles of Y to give 1 mole of a single biodegradable, okay, acyclic polymer Z as the only one product. The amount of the Z formed in the gram is, say yes or no, 500 moles of X, NH2, CH2, C double bond O, OH, NH2, CH2 taken 5, C double bond O, OH. While 2 moles are combining, 1 mole of H2O is going. But here 500 moles, here is 500 moles. Except at the end hydrogen, except for the terminal OH. For every molecule, there will be one H and one OH will be lost. For every molecule, one H and OH. So there are 999 water molecules will be lost, because in every molecule one H and OH, while copolymerization is going to occur. Then who is formed? NH, CH2, C double bond O, NH, CH2 taken 5, C double bond O. Finally, this is the copolymer actually we are getting, which has 500 molecules. Yes or no? A big 1 mole of the compound is formed. But in the terminal itself, hydrogen, in the terminal itself, OH will be there. Say yes or no? How to find out this molecular weight? Simply, so this one molecule, 1 unit molecular weight is 170. So the total overall 1 mole of the compound formed is 170 units into 500 are there, plus at the end one OH and one OH was not lost. That's why I am adding extra 18 molecular weight. After doing so, you will get that 85,018 is the molecular weight. This is the simplest way you are getting the answer. Simple logic. Here 500 molecules, here 500 moles. After all of them combined, a molecule, 1 mole of the polymer is formed. In that 1 mole, there are 500 units are there. Each unit having 170 is the molecular weight. At the end terminal, only one H and one OH will be present. Remaining every molecule, the last one water molecule, that means 999 water molecule we will last. So the final answer should be 85,018 is the answer. Now let us go for the next question. Yes, this is the paragraph question. Consider the following reaction scheme. I am going one by one. First, what is that given? Alpha chloroethanoyl chloride or 2-chloroethanoyl chloride, which on anhydride AlCl3, which undergo electrophilic Friedel-Crafts acylation is occur. Friedel-Crafts acylation rather than alkylation, that is easier. And NaI upon heating, we are getting SN2 mechanism. Iodine gets substituted, followed by what is that? Phenoxide, metanitrophenoxide. Yes or no? This metanitrophenoxide do one more time SN2 mechanism. Then we are getting a compound is a J. The compound J is C double bond O, metanitro compound. Say yes or no? Here is 1 methyl, here is 1 methyl. Now J, this is the J. J on sodium borohydride, which makes, this is carbonyl. All the students here they are doing mistake, because they mention, they may confuse as that is ester, but there is a one CH2 carbon between the C double bond O and O. It is not a ester. Sodium borohydride convert the ketone into secondary alcohol, followed by PBr3, that is bromination SN2 mechanism again occur. Then we are getting the compound is, here is the bromination occur, O, metanitro, and this is the compound. You are getting K, whose compound molecular weight is 350 gram per mole. So molar mass 350. Now you will go for your 2 ways. Which on excess ammonia, we are getting a compound L, What is that happening? Just simply the one and only way, here is the NH2 substitution, O, NO2 and methyl, because this is the happened. And now which one? PHS minus Na plus. That means again here also nucleophilic substitution may occur. That means the compound gets S, PH, O, NO2, methyl. This is the compound M. This is the L, this is the M. Whose molecular weight easily you can get 350 minus of this one, what is that? Bromine 80 minus of this ammonia addition 15. Then we are getting 286 is the molecular weight. Here just bromine 80 removed and thiophene oxide after addition, we are getting the molecular weight as 380. So the compound L and the compound M. Now you go for the question. The volume of 1m aqueous H2SO4 required to completely neutralize ammonia evolved from 5.72 gram of liter in Zeldal method of estimation. You know number of equivalents of H2SO4 is equal to absorbed is equal to number of equivalents of ammonia produced. Say yes or no, which is equal to number of equivalents of nitrogen. Here in the compound there are 2 nitrogens. So 2 ammonia required, just 1 what is that? H2SO4. That means that 2 moles of ammonia means which come from 286 gram, or 1 mole of the compound requires just half mole of H2SO4. Say yes or no? 286 gram of or 1 mole of the compound required half mole of H2SO4. But he was given how much? 5.72 grams. That is 5.72 by 286. That is equal to 0.02 moles. So 1 mole required half mole, then 0.02 moles of the compound required 0.01 mole of H2SO4. Say yes or no? That is 0.01 mole of H2SO4 is required. Now go for the next. We will go for that. Molarity is equal to number of moles into 1000 by V. Then volume is equal to number of moles into 1000 by M. 0.01 mole into 1000 by molarity of the solution is 1. Therefore answer 10 ml. This is the first question answer. You see what is the first question? L compound. L compound molecular weight is 286. So 2 moles of that is 286 gram of the given L compound required half mole of H2SO4. Given moles of compound is 0.02 moles. So 1 mole compound required half mole of H2SO4. In Zeldal method, what is Zeldal method? The ammonia evolved is absorbed by H2SO4. So 0.01 of H2SO4 will be required. From this I found what is the answer as 10 ml. Go for the next question. Same. In the sulfur containing by Carrier's method, the amount of barium sulfate formed from M. Just now we got the M value. What is M? We got S, benzene, O, yes or no? Metanitro, sorry. And this is the compound M, whose molecular weight already we know, that is 380. He is going to ask percentage of sulfur by Carrier's method. Percentage of sulfur is equal to 32 by 233 into, because weight of barium sulfate, barium given as 137, sulfur 32, oxygen 64. Yes or no? 8, 235, sorry, 233. Molecular weight of barium sulfate 233 into weight of barium sulfate obtained from the mixture by weight of organic compound into 100. Okay, you know we have to find out this one only. Already they given weight of the barium organic compound. I want only percentage of sulfur. Percentage of sulfur is equal to number of sulfur atoms into atomic weight of the sulfur by weight of molecular weight of the compound into 100. Say yes or no. That is, number of sulfur present is 1, atomic weight is 32, molecular weight 380 into 100. After doing so, I got that 8.42 percentage of sulfur is present. Yeah, after substituting 8.42 into 233 into molecular weight of the compound 380 by 3200 is equal to weight of barium sulfate. From this, just I have substituted percentage of sulfur there. Got the point? Then weight of the barium sulfate, I got that 2.33. I think here also range will be mentioned mostly, because there is some calculation error will be there for the handwritten. So the answer is 2.33. So in this way, if you know the just compound which was formed, here most of the student doing mistake is here, because after sodium borohydride the student may get confused, is it a ketone or the ester. Got the clarity? Thank you very much, students. Thank you so much.